In the winter of 1941, on the frozen plains near Moscow, German soldiers witnessed something that defied everything they knew about armored warfare. Their most powerful anti-tank weapons ricocheted helplessly against the sloped armor of a machine that seemed to come from another world. The Soviet T-34 tank had arrived on the battlefield, and with it, a revolution that would completely transform the fate of World War II. This is not just the story of a tank. It is the narrative of brilliant minds working under extreme pressure, of decisions that saved a nation, and of how human ingenuity can emerge in the darkest moments of history. To truly understand the impact of the T-34, we need to go back in time, before the explosions and twisted metal, before the titanic battles that define the 20th century. We need to return to the Soviet design offices of the 1930s, where visionary engineers faced a seemingly impossible challenge. The Soviet Union was surrounded by potential enemies. Its vast territory was both its greatest strength and its greatest vulnerability, and the leadership knew that mechanized warfare was on the horizon. The problem was simple to state, but terribly complex to solve. How to create a tank that could be mass-produced, operated by crews with minimal training, survive in the most brutal conditions imaginable, and still outperform the best tanks the rest of the world had to offer. Subscribe to the channel and leave a comment telling us what time you're watching this documentary. Let's discover together how a machine changed the course of history. The story begins with a man whose name should be as well known as Einstein or Oppenheimer, but who remains in the shadows of history for most people. Mikhail Koshkin was a Ukrainian engineer who had grown up in a peasant family, someone who knew the harshness of life in a way that educated aristocrats could never comprehend. Born in 1898, Koshkin lived through revolution, civil war, famine, and forced industrialization. His technical education came late in life, but it brought with it a unique perspective. He didn't design tanks in abstract theory. He designed machines that would need to function in the hands of real Soviet soldiers, traversing real Ukrainian mud, surviving real Russian winters. In 1937, Koshkin was appointed chief engineer of the tank design department at the Kharkov locomotive factory, which had been converted for military production. This was a dangerous time in the Soviet Union. Stalin had initiated the Great Purges, and engineers were particularly vulnerable to accusations of sabotage. Koshkin's predecessor had been removed from his post. Working on military projects meant that every technical decision could be interpreted as treason if the results were not satisfactory. But Koshkin possessed something beyond technical skill. He had the ability to see beyond military specifications, to intuitively understand what a tank needed to be to win not just on paper, but in the real chaos of battle. The challenge Koshkin faced was multifaceted and seemingly contradictory. The Red Army wanted a medium tank that could replace existing models, primarily the BT and the T-26. These tanks had their merits but also fatal flaws. The BT was fast but lightly armored, vulnerable to virtually any anti-tank weapon. The T-26 had better protection but was slow and difficult to maintain. Both had suspensions that failed in Soviet conditions, engines that froze in winter and overheated in summer, and armament that was already becoming obsolete in the face of European developments. Koshkin needed to create something radically different, but to do so within the limitations of Soviet industry, which was still decades behind Western capabilities in terms of manufacturing precision and material quality. Koshkin's first major revolutionary decision was to completely abandon the traditional tank configuration. He studied all available designs from around the world, including captured German prototypes and American tanks acquired through diplomatic channels. What he realized was that they were all stuck in a design orthodoxy that prioritized ease of production over combat effectiveness. Conventional tanks had vertical armor because it was easier to manufacture. They had tall turrets because it facilitated observation. They had gasoline engines because that was the familiar technology. Koshkin decided to question each of these assumptions. Slanted armor became the T-34's most distinctive feature, but its adoption was not straightforward. Slanting the armor meant that, for the same weight, you could get significantly greater protection. A projectile hitting a slanted plate has to penetrate more metal due to the angle, and is more likely to ricochet completely. The math was clear, but the implementation was challenging. Slanted armor created awkward internal gaps, complicated assembly, and required more sophisticated welding techniques. Many in the military hierarchy argued that this would make the tank impossible to mass-produce. Koshkin countered that a tank that could survive enemy attacks was worth any production difficulties. He was betting that the superior protection would save more lives and tanks than would be lost due to manufacturing delays. The second revolutionary decision involved the engine. Most tanks of the time used gasoline engines adapted from trucks or airplanes. Gasoline was volatile. The tanks were vulnerable to catastrophic fires when hit, and the fuel was difficult to transport in large quantities. Koshkin insisted on a diesel engine, specifically the V2, a 12-cylinder V-shaped engine that was being developed for aeronautical applications. Diesel was safer, provided greater range per liter, and was less prone to freezing in extreme cold. But diesel engines were heavier, more complex to manufacture, and there were doubts about whether they could provide enough power for a battle tank. Koshkin worked directly with engine engineers, adjusting specifications, testing prototypes, accepting failures and learning from them. The end result was an engine that produced 500 horsepower, capable of propelling the T-34 to speeds of up to 55 kilometers per hour on favorable terrain. The Christie suspension was another crucial innovation that Koshkin adapted and perfected. J. Walter Christie was an eccentric American inventor who had developed a revolutionary suspension system using large wheels and coil springs. The United States Army had rejected his designs as impractical, but the Soviets bought the rights and began experimenting. Koshkin saw the potential of this suspension to create a tank that could move quickly through uneven terrain without shaking the crew into insensibility or breaking critical components. He modified the Christie design, increasing the size of the wheels, adjusting the springs, and integrating the system in a way that maximized internal space. The result was a tank that had exceptional mobility even in conditions that would immobilize conventional designs. Regarding armament, Koshkin faced intense debate. Some military commanders wanted multiple smaller guns to engage diverse targets. Others argued for larger cannons that could penetrate any armor. Koshkin chose a middle ground that would prove ingenious: a 76mm cannon derived from a standard Soviet field artillery piece. This cannon had several advantages. Ammunition was already in mass production for other military applications, which would simplify logistics. The caliber was large enough to penetrate the armor of any known German tank at the time, but not so large as to make the tank unbalanced or overload the structure. And crucially, the cannon could fire both armor-piercing and high-explosive ammunition, making the T-34 equally effective against tanks and infantry. But while Koshkin worked on his revolutionary design, he faced opposition from all directions. Conservative military officials preferred the A-20, a more conventional design that Koshkin had been forced to develop in parallel as a safe option. The A-20 was essentially an evolution of the existing, familiar, and less risky BT tank. There was enormous pressure to simply approve the A-20 and begin mass production. But Koshkin knew that familiar did not mean adequate. He argued in meeting after meeting that the A-20 would be obsolete before it even entered large-scale production, that the Germans were developing anti-tank weapons that would make it vulnerable, that the Soviet Union needed a tank that would set standards for the next decade, not one that copied standards from the last. The situation had reached a political impasse. The bureaucrats wanted security. The generals wanted numbers. Koshkin wanted excellence. So he made a decision that was either brilliant or insane, depending on how you looked at it. In the spring of 1940, with two newly completed T-34 prototypes, Koshkin proposed a dramatic demonstration. He would drive the prototypes from Kharkiv to Moscow, a journey of over 700 kilometers through primitive roads and muddy fields, demonstrate the tanks to Stalin and the Soviet leadership, and then drive them all the way back. This would be the ultimate proof that the T-34 was not only superior on paper, but in the brutal reality of Soviet geography. The journey began in March, when the spring thaw was turning the roads into rivers of mud. Koshkin personally commanded one of the prototypes, with a small team of engineers and mechanics following in support trucks. They faced every challenge that the underdeveloped Soviet infrastructure could offer. Bridges barely able to support the weight, mud that swallowed the wheels up to the axle, freezing night temperatures that tested every mechanical component. And the T-34s kept moving forward. They crossed rivers where bridges had collapsed. They climbed hills that other vehicles considered impassable. When they arrived in Moscow, they were covered in mud and scratches but functional. The demonstration for Stalin and the senior officers was meticulously planned. The tanks performed maneuvers that would be impossible for conventional designs. They accelerated and braked sharply, showing exceptional control. They climbed obstacles that were higher than the wheels. They fired on the move, demonstrating weapon stability. And perhaps most impressively, they withstood direct fire from anti-tank guns that would destroy any other Soviet tank. Stalin, notoriously difficult to impress and suspicious of anything that seemed too good to be true, asked detailed technical questions. He wanted to know about reliability, ease of maintenance, and how long it would take to train crews. Koshkin had answers for everything, based not on theory but on thousands of kilometers of practical testing. Approval came, but with conditions. Production of the T-34 would begin, but the A-20 would also continue development as a backup. Factories would need to be retooled, workers retrained, supply chains reorganized. And all of this would need to happen quickly, because the clouds of war were gathering on the horizon. Koshkin should have been triumphant. He had overcome all the skeptics, proven his design, secured the future of his creation. But the journey had taken its toll. During testing in Moscow, Koshkin had been soaked several times, working in freezing rain to make repairs. He developed severe pneumonia that turned into something much worse. Even as the first production T-34s began rolling off the assembly lines, Koshkin was dying. In September of 1940, Mikhail Koshkin died at the age of 42, having created the tank that would save his nation but never living to see its full impact. He was buried in Kiev, and the Soviet leadership, belatedly recognizing his genius, posthumously awarded him the Stalin Prize. But awards were poor consolation. Koshkin's true legacy was only beginning to unfold on the plains of Eastern Europe, where historical forces were about to collide with unprecedented intensity. When Germany launched Operation Barbarossa in June 1941, the Red Army had only about 1,000 T-34s in service. Most Soviet armored units still operated the older, more vulnerable tanks that Koshkin had sought to replace. The Germans had numerical superiority, tactical superiority, and years of combat experience from the Polish and French campaigns. In the first days of the invasion, Soviet forces suffered heavy losses. Thousands of tanks were destroyed or captured. Entire units were surrounded and neutralized, and it seemed that nothing could stop the German advance toward Moscow. But then the Germans began encountering the T-34 in increasing numbers, and their confidence began to waver. Field reports from panzer commanders described encounters that challenged belief. German 37mm guns, which had been effective against Polish and French tanks, were completely useless against the T-34. Even the 50mm gun, the standard German anti-tank weapon, frequently failed to penetrate sloped armor at any reasonable distance. Lighter German tanks, such as the Panzer II and Panzer III in their initial configurations, found themselves completely outmatched. The T-34's 76mm gun could neutralize them at distances where they could not effectively retaliate. A German officer wrote in his diary, "Our intelligence reports were completely wrong about Soviet capabilities. These T-34s are monsters. Nothing we have can stop them head-on. We are forced to use desperate tactics, attacking from the flanks or trying to disable their tracks. It is terrifying to face a machine against which you are powerless." Another commander reported seeing a T-34 take 23 direct hits from anti-tank guns without being penetrated, before finally being immobilized by a lucky shot to the track. But the T-34 didn't win the war solely through technical superiority. In fact, in the early months, many T-34s were lost for reasons that had nothing to do with deficiencies in the tank's design. Soviet tank doctrine lagged years behind the German one. Crews were inadequately trained. Many tank commanders didn't understand how to effectively use their superior machines. Logistical problems meant tanks ran out of fuel or ammunition. A lack of radios in many tanks made coordination impossible. And perhaps most problematic, the Soviet military leadership had been severely affected by Stalin's purges, leaving inexperienced officers in command of complex formations. The Germans quickly developed tactics to compensate for their technical inferiority. They used teamwork, with lighter tanks luring T-34s into traps where heavy 88mm anti-tank guns awaited. They attacked from ambush, targeting the tank's least protected parts. They used grenades and explosive charges in close combat. And critically, they worked to accelerate the development and deployment of better weapons. The Panzer IV was improved with a long-barreled gun that could penetrate the T-34. New anti-tank weapons were rushed to the front. And in German design bureaus, work began on what would eventually become the Panther, a tank that would blatantly copy many of Koshkin's innovations. But while the Germans adapted, so did the Soviets, and here the true genius of Koshkin's design became apparent. The T-34 was not just an excellent tank, it was an exceptionally adaptable design. Its fundamental characteristics, sloping armor, powerful diesel engine, robust suspension, created a platform that could be continually improved without completely redesigning the tank. When it became clear that the 76mm gun was beginning to fall short against the newer German tanks, engineers were able to install a much more powerful 85mm gun in the T-34-85 without dramatic changes to the basic structure. When production needed to be accelerated, simplifications could be made without compromising essential effectiveness. The mass production of the T-34 was in itself an epic feat of industrialization under extreme pressure. As the Germans advanced deep into Soviet territory, the factories producing tanks were directly threatened. The decision was made to evacuate entire industrial facilities eastward, beyond the Urals, where they would be out of reach of the Luftwaffe. This wasn't simply moving offices or paperwork. It meant dismantling entire factories, loading 100-ton stamping presses, foundry furnaces, complete assembly lines onto freight trains, and transporting them thousands of kilometers. Workers and their families went along, rebuilding not only factories but entire cities in the Siberian wilderness. In Tankograd, the tank city built from scratch in Chelyabinsk, workers toiled 16-hour shifts in temperatures that reached 40 degrees below zero. Many were women, children, and the elderly because the young men were at the front fighting. They learned to weld, operate lathes, assemble engines, all while living in makeshift barracks and surviving on inadequate rations. Quality inevitably suffered. Tanks came off the assembly lines with rough finishes, uneven welds, and components that barely fit together. But they worked, they could fight, and most importantly, they were produced in numbers that the Germans couldn't match. The scale of production was astonishing. In 1942, Soviet factories produced over 12,000 T-34s. By 1943, that number had risen to 15,000. In total for the war, over 57,000 T-34s were built, making it the second most produced tank in history. Compare that to German production. The Germans built approximately 6,000 Panthers, fewer than 1,500 Tigers, numbers that simply could not compensate for the losses they were suffering on all fronts. The Germans had technically sophisticated designs, but they paid the price in manufacturing complexity. A Panther took twice as long to build as a T-34 and required scarce materials and engineering precision that besieged Germany could no longer supply in adequate quantities. The T-34's simple design also meant it could be repaired in the field with basic tools and standard parts. Crews learned to perform extensive maintenance without needing to send tanks back to depots. Damaged tanks were cannibalized for parts to keep others running. Standardization meant that a component from a T-34 built in one factory would often work in a tank built in a completely different factory. The Germans, with their proliferation of models and variants, each with unique parts requirements, faced logistical nightmares. German tanks were often abandoned not because they were destroyed beyond repair, but because the necessary part simply wasn't available. As the war progressed, the T-34 became more than just a military tool. It became a symbol of Soviet resistance, an icon representing the nation's ability to withstand and eventually overcome the German war machine. Soviet propagandists extolled the tank in posters, films, and songs. Factory workers painted patriotic messages on the sides of tanks as they rolled off the assembly lines. For Stalin, for Moscow, revenge for our fallen comrades. Frontline units adopted individual T-34s as mascots, giving them names and decorating them with battle art. The tank became intertwined with the national narrative of survival and victory. In the great battles that defined the Eastern Front, Stalingrad, Kursk, the Bagration Offensive, the T-34 was fundamental. At Kursk, the largest tank battle in history, more than 6,000 tanks clashed in combat that lasted weeks. The Germans had assembled their best armored formations, including the newly deployed Tigers and Panthers, for an offensive they hoped would restore the initiative. The Soviets, warned by intelligence about the attack, prepared deep defenses and concentrated enormous reserves of T-34s. What followed was a confrontation of incomprehensible scale. Battlefields were littered with damaged equipment. But when it was all over, it was the Germans who retreated, their armored force significantly reduced. The Soviets had lost more tanks in absolute numbers, but they could replace their losses. The Germans could not. Soviet engineers continued to refine the T-34 throughout the war. The T-34-85, introduced in 1944, represented a major upgrade. The turret was redesigned to accommodate the larger 85mm gun, which finally gave the T-34 a reliable advantage over the best German tanks at normal combat distances. The crew was increased from 4 to 5, with a dedicated loader allowing for a higher rate of fire. Sight and communication were improved with better sights and more reliable radios. But fundamentally, it was still the tank Koshkin had conceived, its design principles vindicated through millions of kilometers of combat. The T-34's influence extended far beyond the Soviet Union itself. After the war, the tank was supplied to Soviet allied states around the world. It saw combat in Korea, where North Korean T-34s initially dominated South Korean and American forces until better tanks and anti-tank weapons arrived. It fought in the Middle East in several Arab-Israeli wars, although by the 1960s it was clearly outdated by more modern designs. It was used in African, Asian, and Central American conflicts, becoming the tank of choice for revolutionary movements and states with limited budgets. Even into the 21st century, T-34s were still in service with some armies, a remarkable longevity for a design originating in the 1930s. The impact of the T-34 on tank design theory was profound and lasting. Almost every tank designed after World War II owes something to Koshkin. Sloping armor became a universal standard. Diesel engines replaced gasoline engines in military applications. The concept of a general-purpose tank that balances protection, mobility, and firepower rather than specializing in one area became the dominant philosophy. Even modern tanks like the American M1 Abrams or the German Leopard 2 can trace their conceptual lineage back to the T-34. There are endless debates among military historians and enthusiasts about whether the T-34 was truly the best tank of World War II. Some argue that the German Panther was technically superior. Others point to the American Sherman as more balanced. But these debates often miss the point. The T-34 didn't need to be the best tank in any specific category. It needed to be good enough at everything that mattered, and be produced in overwhelming numbers. It needed to function in the hands of poorly trained crews under terrible conditions. It needed to be reparable under fire. It needed to terrify the enemy simply through its omnipresence. In all these aspects, it was a spectacular success. The human story behind the T-34 is as fascinating as its technical history. The dozens of engineers who worked on its development, many whose names have been lost to history. The metallurgists who developed the special steel alloys used in its armor. The ballistics experts who calculated ideal armor angles. The engine engineers who made the V2 reliable. The suspension designers who adapted the Christie system. Each contributed essential pieces to the puzzle, but it was Koshkin's unifying vision that brought it all together into a coherent whole. Consider also the crews who fought in those tanks. Living in claustrophobic conditions, constantly covered in oil and dirt, deafened by the roar of the engine and the burst of the cannon, facing constant dangers. The challenges were immense. Yet, they continued to fulfill their duty, climbing into new T-34s when necessary, because the alternative was defeat and occupation. There is also the often neglected economic dimension. The T-34 was remarkably cheap to produce compared to equivalent tanks. Estimates vary, but a T-34 cost approximately one-third the price of a German Panther and less than half that of an American Sherman. This meant that for the same investment of resources, the Soviet Union could put 2 or 3 times as many tanks on the field. In a war of attrition, where both sides were losing equipment at staggering rates, this cost advantage became decisive. The mundane economics of mass production proved to be as important as any brilliant technical innovation. The story also raises questions about the nature of innovation and leadership. Koshkin operated within a system that was brutally punitive for failure, where mistakes could result in serious consequences. Yet, he had the courage to defend a radical design against massive institutional opposition. He risked his career and life in a dramatic demonstration of his prototype. He worked to the point of destroying his health. Was this extreme pressure necessary for his genius, or would it have propelled him to even greater heights under different circumstances? How much human potential was lost because other engineers did not survive the purges or had their careers ended for not producing immediate results? There is also the paradox of a tool of destruction being celebrated as an engineering achievement. The T-34 saved the Soviet Union, but it did so in combat against German forces. Every conflict had its human cost. Every village liberated by Soviet forces equipped with T-34s had previously been occupied. Can we admire the design while lamenting its purpose? The answer likely lies in recognizing that war forces societies to make difficult choices, and that the T-34 represented a choice to resist aggression. Looking at modern documentaries and military histories, it's surprising how many focus on German tanks, particularly the Tiger, treating it as the ultimate tank of the war. This partly reflects source bias, as German memoirs were more readily available to Western historians initially. But it also reflects a fascination with advanced technology over practical effectiveness. The Tiger was indeed an impressive machine, but it was produced in minuscule numbers and was notoriously unreliable. A broken Tiger is just immobilized metal. A functioning T-34 is a combat threat. Military history is finally beginning to give the T-34 the recognition it deserves as the truly transformative tank of World War II. Mikhail Koshkin's legacy is complex. He died poor and relatively unknown. His name isn't a household word even in his homeland. There are no multinational corporations bearing his name like there are for Ford or Porsche. Yet, his creation shaped the world in ways few inventions have. The T-34 allowed the Soviet Union to survive and eventually defeat Nazi Germany. Without it, the history of Europe and the world would have been radically different. It's difficult to imagine the Soviet Union resisting the Wehrmacht with only its oldest tanks. What if the Soviet Union had fallen? What would Europe have looked like under Nazi rule? What terrible consequences would have ensued? These counterfactual questions highlight the importance of Koshkin's work. There is also the question of technical legacy. How many of the engineers who now design military equipment were inspired by stories of the T-34? How many innovations in metallurgy, engine design, ballistics can trace their lineage back to developments made for Koshkin's tank? Engineering is a cumulative field, where each generation builds upon the achievements of the previous ones. The T-34 represents a quantum leap, a point where multiple innovations came together to create something truly revolutionary. These moments are rare and worth studying not only for their historical interest, but for the lessons they offer about how innovation happens. One of these lessons is the importance of questioning orthodoxy. Koshkin could have simply iterated on existing designs, made incremental improvements, and produced a perfectly acceptable tank that would be forgotten by history. Instead, he asked fundamental questions about what a tank needed to be. He challenged assumptions about armor, propulsion, suspension, armament. He was willing to rethink everything from the ground up. This willingness to start from principles first, rather than accepting established conventions, is characteristic of genuine advancements in any field. Another lesson is about testing and iteration. Koshkin didn't just draw the T-34 on paper and declare it a success. He built prototypes. He tested them to destruction. He flew them thousands of miles through the worst possible conditions. He listened to feedback from test crews. He made modifications based on real results, not abstract theories. This iterative refinement process, though time-consuming and frustrating, produced a design that worked in the real world rather than just in theory. Many projects fail because they neglect this critical testing phase, assuming that if something works in theory, it must work in practice. A third lesson involves balancing conflicting specifications. The T-34 wasn't the most armored or the fastest or the most heavily armed. It struck an ideal balance where it was good enough in all those dimensions while remaining producible and maintainable. Engineering always involves trade-offs. Improving one feature usually comes at the cost of another. Koshkin's genius lay in understanding which trade-offs were worthwhile and which were not. He prioritized features that mattered in real combat over those that looked impressive in specifications. Finally, there is a lesson about perseverance in the face of adversity. Koshkin worked in one of the most repressive societies in modern history during one of its most dangerous periods. He faced stifling bureaucracy, political opposition, institutional distrust, inadequate resources, and the constant threat of punishment for failure. Many would have given up or compromised their vision to appease critics. Koshkin refused. He believed in his design and fought for it until others saw what he saw. This combination of conviction and courage is rare and precious. As we reflect on the history of the T-34, we must not lose sight of the monumental human cost of the war that necessitated it. The Eastern Front was the most intense theater of World War II. Millions lost their lives. Entire cities were reduced to rubble. Civilian populations suffered terribly. In this context, celebrating a weapon of war may seem inappropriate. But the T-34 also represented survival, the ability of a people to defend their existence against an existential threat. It is this dualism that makes the story so complex and worthy of careful contemplation. Museums around the world now display preserved T-34s, where visitors can see firsthand the product of Koshkin's genius. Touching the thick armor, examining the carefully calculated angles, peering inside the cramped interior, gives some visceral sense of what these machines represented. But monuments and museums can only capture so much. The true measure of the T-34's impact lies in history books, in the borders that exist or don't exist, in the lives that were saved because the Soviet Union could withstand German aggression. Historical counterfactuals are speculative, but it's reasonable to argue that without the T-34, the 20th century might have unfolded drastically differently and far more darkly. Today, in an era of drones, laser-guided missiles, and cybersecurity, the tank as a combat platform is often declared obsolete. However, recent conflicts have demonstrated that heavy armor still has a role on the modern battlefield. The principles Koshkin established, protection, mobility, firepower, producibility, remain relevant. The design challenges he faced, such as balancing conflicting specifications, optimizing for real-world conditions rather than idealized scenarios, and creating systems that can be maintained and repaired by personnel with limited training, persist throughout military engineering and beyond. The story of the T-34 is ultimately a story about human potential. It's about what can be achieved when brilliant minds are given important problems to solve and the freedom to find radical solutions. It's about how extreme pressure can sometimes catalyze exceptional creativity, though often at a terrible cost. It's about how one person, working with a dedicated team, can create something that changes the course of world history. Mikhail Koshkin was an ordinary man of humble origins who became, through talent, hard work, and courage, one of the most important engineers of the 20th century. If we could speak to Koshkin in his final days, as he lay ill knowing he wouldn't see his creation prove its worth, what would he think about his legacy? Would he be proud that the T-34 saved his nation? Reflective on the consequences of his invention? Satisfied that his engineering principles would prove so enduring? Frustrated that his name would remain obscure while less deserving political figures would be remembered? Probably all of that and more. Historical figures are complex, and reducing Koshkin to a single dimension would be an oversimplification. What should we make of this story? For engineers, it offers inspiration and practical lessons. For historians, it provides insight into how technology shapes geopolitical events. For moral thinkers, it raises difficult questions about the development of destructive technologies even for defensive purposes. For the general public, it reminds us that common and unnoticed objects, in this case a tank that eventually became so commonplace that it was taken for granted, have origins in extraordinary human endeavor, often under extraordinary circumstances. There is perhaps a melancholic comfort in knowing that even during the darkest periods of human history, when entire nations are in conflict on an industrial scale, there is still room for brilliance, innovation, and even a certain kind of beauty in pure functionality. The T-34, for all its destructive nature, also represents the human capacity to solve complex problems, to adapt, to create tools that meet its needs. That these tools are sometimes instruments of war does not diminish the intellectual achievement they represent, although it certainly complicates how we should think about them. As we conclude this exploration of the genius behind the T-34, it is worth considering that there are likely countless other Mikhail Koshkins throughout history, people whose contributions shaped the world but whose names have been forgotten. How many brilliant engineers remained unknown? How many potential innovations never happened because someone with the talent to create them didn't have the opportunity, or was prevented by circumstances? The fact that we know Koshkin's story is almost accidental. He could easily have been another victim of the purges, his design ignored, his potential wasted. That we came so close to losing his contribution highlights how fragile our civilizational advances are, how dependent we are on specific individuals being in the right places at the right times. But he was there. He asked the right question. He found the right answer. He defended it when others doubted. And because of that, the course of history changed. The T-34 roared across the plains of Eastern Europe, its diesel engines thundering, its sloped armor deflecting projectile after projectile, its 76mm cannon speaking with ultimate authority. It was a machine, but it was a machine born of human vision, created by human hands, driven by human will. It was Koshkin's genius transformed into steel and fire, and it was nothing less than revolutionary. May we remember Mikhail Koshkin not only as an engineer, but as an example of what humanity can achieve when necessity, opportunity, and genius converge. May his struggles and triumphs remind us that progress is never automatic, always hard-won, and often due to individuals who risk everything to make their visions a reality. May the Lord God grant rest to all those who gave their lives in the great war that the T-34 helped to win, and may we learn from this story to seek peace through strength, but always prefer peace to war when it can be honorably achieved. And may we never forget that even in the machines of war, there is a human spirit, for good and for evil, shaping the world around it.